pen, trig identities. Now, earlier in this topic, we have dealt with a couple of different trig identities already. Okay, so some of the trig identities that we've dealt with are things like the sine of 180 minus x is the same as the sine of x. And that was called the reduction formula. We've also dealt with things like this, where we say the sine of 90 minus x is the same as the cos of x. Now that's an identity, and that is what's called a co-ratio. Okay, and this was called the reduction formula. And we could also get things like the cos of 360 minus x equals the same as the cos of x. That was also still just the reduction formula. Give me a thumbs up if you recognize those trig identities. There are many more, but I just want to see that you recognize them as identities. The one left-hand side is equal to the right-hand side. Give me a thumbs up if you've seen these identities before I move on to the new ones. Oh, fantastic. Okay, now, we also need to know about two other identities. So what are those two other identities? They're going to get a lot of attention today. The one is called the quotient identity, and it says that the tan of x is the same as the sine of x over the cos of x. So that's called the quotient identity, because there's a quotient or division. And the other identity we need to know about is this one, and this is called the square identity. Now, the square identity can actually be rewritten in two other ways. The other way it can be written is sine squared x equals 1 minus cos squared x, which is basically I've just moved the cos squared x in this identity. I've moved it to the other side. So it's the same identity, it's just been rearranged. And then you can also rewrite this as cos squared x equals 1 minus sine squared x. This is the same identity, it's just a different way of writing it. So the main focus today is going to be on these two identities. Give me a happy face if you've seen these before. Give me a unhappy, or give me a thumbs up if you've seen them. Give me a thumbs down if you've not seen them. Okay. So don't worry if you haven't seen them before. Just notice that there are identities, and I'm not going to go into the full explanation of why they are, but I'll give you a brief look at them to start with today. So the main idea that we're going to practice today is using them. But just to show you, if we think about when we started with trigonometry, in grade 10, we used this idea of SOHCAHTOA. Okay. So SOHCAHTOA, but in grade 11, we extended this so that we can think of the O as the Y, the H as the R, the A as the X. So if you think about it, this SOHCAHTOA in grade 11 can be rewritten like, maybe it's even better just leave it with the small things on top. Anyway, okay, let's do it like that, where we replace it. Now, if you write the sine of theta over the cos of theta, that is the same as writing y over r divided by x over r. But if you're dividing by a fraction, if you change the division to a times and you flip the two things over, what you're going to end up with is that, right? So x over r becomes r over x because it became a times. So let me start with that. Now, what you'll notice is that there's an r on the bottom and an r on the top. So what are you left with? You're left with y over x is the same as that. But what do you know about y over x? Well, y over x is up here, and y over x is actually just tan. And so you know that in fact, the sine of theta over the cos of theta is the same as the tan of theta. Or I wrote it with x's, but this is called the quotient identity. Give me a thumbs up if that base, I'm not saying expecting you to get this perfect, but just tell me if that argument sort of makes sense for why the tan of x is the same as the sine of x over the cos of x. So give me a thumbs up if you sort of see that. Give me a thumbs down if you didn't follow that argument. Let me see the thumbs of the people in the room. Yeah. Okay, now, same thing with the sine squared and stuff. Here is sine squared theta plus cos squared theta. Now, using what we did above, sine of theta is y over r. Cos of theta is x over r, right? So we've already got that already above. But we are now going to write them as squareds. So we've got y over r squared and x over r squared. But if we square those, we get y squared over r squared plus x squared over r squared. And you know what? They both have the same denominator, which is r squared. And we can also add together the x squared plus the y squared. But if you look at this from the theorem of Pythagoras, we know that x squared plus y squared is r squared. We know that is true. So we can replace the thing in blue with r squared. But then what is r squared over r squared? It's just going to be 1. And so what we can then say is that sine squared theta plus cos squared theta equals 1. Or the way I said it was sine squared x plus cos squared x equals 1. And that can be rewritten in different ways. So take a screenshot if you want now of the sort of proofs of these, but the proofs aren't examined that often. The main idea is you want to be able to use these identities, but just take a screenshot if you need to now before we get going. Alrighty. So let us go on to the first question of tonight. So we are going to try and simplify that trig expression. Now, the main tool that I think you're going to use is one of those two identities. Which identity do you think I'm going to use? You can put your hand up or you can put it in the chat. The goal is to simplify that expression. So Sange has said, replace the sine of alpha with, or replace the tan of alpha with the sine of alpha over the cos of alpha. I agree. I agree. But now we are stuck with that thing. Can anybody help us move? I agree. It's the great thing to do. But how do we move forward from that? Maybe we can use one of the techniques I spoke about now. What do you do if you're dividing by a fraction? What do you do if you're dividing by a fraction? Can we do anything with this to make it a bit more user-friendly? So we have sine of alpha, but that's a mess at the bottom. I think I can write that over 1. And then if I tip and times it, I'm going to get cos of alpha on the top and sine of alpha on the bottom. And then what are we going to end up with for that in the end? Yeah, Sange reciprocal. Perfect. What's my final simplification for this going to be? I think we are just going to cancel out those two, and we are left with the cos of alpha. So that was a simplification question dealing with trig identities. Give me a squad of 10. 10 if you feel like you understood it perfectly. 0 if you feel like you didn't understand it at all. 5 if you sort of understood it. Let me know how you're feeling about that. I know how quickly I can go with the next one. Just give me a squad of 10. Let the people speak. Let them, because then I can know how many examples I can do with you today. Okay. All right. Then, for the second question today, I want you to try and simplify this trig expression. So I'll leave the old one up just to help you a little bit, but can you simplify this trig expression? And if you're feeling generous, you can give a tip in the chat about where you would start. Which thing would you start by replacing if you're feeling generous? Okay, who's giving some? I was thinking, I feel like maybe this tan over here could be replaced. So that's the hint I'm going to give you. And then let me know if you have a question by putting your hand up, or say done in the chat if you feel like you're done with simplifying that trig expression. What do you think? I think that's a good place to start, but I don't know how it's going to finish. So I'm replacing that with this. But now what should I do next? Because these have to be equal, huh? So now the question is, what do I do next? Well, you know what? This is all actually over the same fraction. So I feel like I can cancel out those two, which then leaves me with that. Now that is feeling very familiar. What do we think 1 minus sine squared theta will be equal to? It's reminding me of the square identity. So what was the square identity? It says that sine squared theta plus cos squared theta is 1. And then I feel like I can move this to the other side. So this must be cos squared theta. So that will be my answer. This whole thing over here can get simplified down to cos squared theta. All right. Let us now focus on another question. I want you to do number 4 for me. Can you simplify number 4 by yourself? See what you can do. And then raise your hand for a question or give a question in the chat or say done when you're done. See if you can do number 4. Who has an idea they can share with us? This is reminding me of one of the identities, and I feel like it could probably help if I recognize which one. So just put done in the chat when you're done. Until that point, I'm not going to go any further. I'll give you a little hint. I think that this top thing can be replaced with sine squared theta. The question is, what is going to go in the bottom part? Well, if I look at this, I've seen already this has to be cos squared theta. So what's my final answer going to be? What is my final answer going to be? So I've replaced that with that. Sine squared theta over cos squared theta. If it's easier, you can just pop your hand up and let me know audibly. What do I get for that? I think that's reminding me of the tan identity, and I'm going to get tan squared theta. And so that would be my final answer for that one. All right, let us move on to number 3. So I want you to try and use substitution and the trig identities we've dealt with so far today to try and help you simplify question 3, which is in green. And then if anybody is feeling confused, I want you to just raise your hand, because I might be going too fast, but it's hard for me to tell at the moment because there isn't too much going on in the chat or but if you're feeling happy and things are going swimmingly, then just give me a thumbs up. Then I know that we're in the same ballpark. Okay. What is our first step going to be? That's what I want to know. Where would you start question 3? Amelia, what do you think? Rulani, would you start with the cos or would you start with the tan? What would you start with? The tan. Okay, fantastic. So if we start with the tan, Amelia, I'm guessing you want to replace this as sine squared theta over cos squared theta. So let's do that. So the cos squared theta can stay out in front. The 1 can stay there, but here I have sine squared theta over cos squared theta. What would you do next, Amelia? I agree with you. That seems to me like a good step. What would you do next? I don't know if anybody else did what Amelia did, but we're kind of now a bit stuck because it still feels like there's more. Factor out cos, I guess. Almost. I would say we distribute the cos would be the fancy word for it. So if I multiply cos squared theta by 1, I get cos squared theta. But what do I get when I multiply cos squared theta by sine squared theta over cos squared theta? What are we going to get? I'll put a black box. What do we think goes in the big black box? Rulani, you are absolutely correct. Because what happens is the cos squared theta cancels out the one on the bottom. Okay, now, final step. What is going to be in the box? The big green box. I think that reminds me of sine squared theta plus cos squared theta. It's just the other way around, but it doesn't matter because it's a plus. So this is exactly the same as saying sine squared theta plus cos squared theta, which then must be 1. You guys are getting this. So, yeah, I think that I'll give you a second to take a screenshot if you would like to record what's there, but I think I can move you on to one more question before the break, but you're making really good progress. Yeah, so I think I can keep going up in difficulty unless there's a question. All right. I want you to try and simplify this one for me. We'll call this number 5. Now, this is a little bit trickier, it looks like, but yeah, maybe if we share our knowledge, we can do it together. So put in the chat what you would start with doing in number 5. What's standing out for me is that this term over here has a tan squared, and this one over here has a tan squared. So Rulani's asked, can you take out the tan on both sides and drop it? Okay, sort of. Not quite. There aren't two sides here, Rulani, so there's only one side. But what you could do is you could take the tan squared theta out by a process called factorizing. And so what do you think is going to go inside this? If you take out the highest common factor of this, well, what's left behind is going to be cos squared theta plus sine squared theta. So we can't drop it in the sense of there's not two sides here, but what you can do is factorize. Now, what do you think we're going to do from there? What do you think we're going to do from there? That cos squared theta and sine squared theta seems to pop up everywhere, doesn't it? Well, I actually know what this bracket's value is. So if I know what this bracket's value is, it's going to be, actually, it's going to be 1. Yeah. And 1 times anything means that the final answer for this, after all that mess, is just going to be a tan squared theta. So what you notice is there's a couple of different techniques you have to use. The one is tip and times for fractions. The one is factorizing. The other one is canceling. These are all toolkits or tools in your toolbox that you'll get used to using. But we have done quite a lot of work already today, and I think it's important we take care of our bodies. So please, everyone, join me in turning on your cameras so you can see your classmates, and join me in indulging your silly side a bit, so that your body can keep on learning. We know it's been a long day, and so you want to make sure you get maximum value for your time. So what does our body run on? It runs on oxygen. So let's get some oxygen. So let's breathe in. Breathe out. Last one, breathe in. Okay, so we've got some oxygen, which will help us unwind, but we want to just shake our arms out a little bit, get some circulation going. So get some circulation, because you've been sitting, you've been passive, your body wants to move. So just flail your arms around nice and loose, like you've got no stress in the world. Then shake out your legs a little bit. And it really helps to do this. I know it feels a bit a bit like, I don't know, random, but this, after a while, your body starts to really appreciate it. I know I can feel as the teacher. It makes me feel so much more relaxed. Okay, let's roll our shoulders back, loosen them up. And then let's roll our arms forward. Feeling so nice and relaxed now. Then arms out. Let's do some small circles. Going forward. And then small circles going backwards. And then another one for your shoulders is triceps. So if you do a tricep stretch like this, and then go to the other side. Oh, that feels good. Maybe even just stretch your neck to one side like this. On the other side like this. And then one last shake. Shake of the arms. Shake of this arm. Shake of this leg. Shake of the other leg. Okay, now to get, so we've got oxygen, we've de-stressed a bit, now it's time for some blood flow. So we're going to pump the blood through our body through jumping jacks. You all know how it goes. That is a jumping jack, and we are going to do 15 of them in 3, 2, 1. Let's go. 3, 6, 7, 8, 10, 11, 12, 13, 14, 15, and that is it. And in 3 minutes, I feel like I have completely reset my concentration span. How is your concentration span feeling after that? I feel like my heart rate's up though, but yeah. And then can you make 24 using either the red card or the blue card? Give your brain a moment to just wander around and solve a puzzle that isn't related to the work for today, but it's just a fun puzzle. Okay, who feels like they have got an answer for this one? Any ideas for the red one? We have to do at least one before we carry on. How would we make 24 with the red one? What do you think, Rolani? Sange? 8, 1. I think one of the main steps is to go 8 minus 5. Can you get to 24 once you have that? Okay, so if I've used the 8 and the 5 to give me 3, then I think I can take the 7 and the 1 to give me 8. And then I get 3 times 8 is 24. Okay. Let us go back to the trig questions we were doing. I want you to try and simplify this expression. So brownie points if you can tell me where you would start, but I want you to try and do that. And then in the chat, I want you to tell me where you would start, or if you're done, you say done. How would you simplify? It's looking a bit more complex, that trig expression. Where would you start? Let me know. Okay. Stephen, do you want that one? Okay, cool. I think there are two choices. You either start with this bit here, or you start with this bit here. So give me a B in the chat if you think, oh, Stephen, you're done. Fantastic. Would you start with the B in blue or the G for green? Where would you start when simplifying this expression? Give me a B or a G for where you think we should start. I'm going to start with the green, and I think I can write the green bit as sine squared b, and then the cos squared b is the same on the bottom, and then I've just got that bit. What is my next step going to be if I do that? What should I do next? If I've replaced the green bit with this, what should I do next? Oh, yes. So I think we can change sine squared beta over cos squared beta to just tan squared beta, and then you've already got a minus tan squared beta already. So what is my final answer going to be? What is the final answer going to be? I think anything minus itself needs to be 0. All right. Now, I have some time. We have about 15 minutes left. I wanted to see if I must go up in difficulty or if we still need to do more of these types of questions. So give yourself a 10 out of 10 if you're getting this perfectly. Give yourself 0 out of 10 if you don't understand it at all. 5 if you sort of understand it. Where would you put yourself on your understanding scale at this point? Where would you put your understanding at this point? Okay, Sange is locked in an answer. Who else can give us a sense of where they think they are in terms of understanding? Amelia, 7.5. Okay. So would it be wrong to factorize the cos or to change the 1 to cos squared plus sine squared equals 1? Ooh, interesting. You could change the 1 to cos squared. You could also do that, yeah. So Rolani, there's actually a couple of ways you could have done this one above, but as long as you got the same answer, you would be fine. Okay, so we're all about in the range of 7, so that's fine. We can do this one, and then we'll move on to the next type of question. What is different about this question? It says simplify, so we've still got to simplify it like before, but something feels a bit different. We could replace something, but I don't know what. I'm drawn to this top line. This top line looks a bit tricky, but maybe what should I do on the top line to start the simplification process? Who has some ideas they're willing to share? We sort of used this technique earlier in the lesson. So it's like that we want to uncomplicate the top line. Don't the signs cancel out? They don't yet, Sange. You're on the right track, but what you need to do is you actually need to, oh, Rolani, yes, you need to factorize. So you can't cancel the signs out yet because you need to first take out the sine of theta as a factor. Now, what do you think goes inside the bracket if I take out the sine of theta? I want you guys to tell me what goes inside the bracket using your powers of factorization. Well, there's a 1 for that part, and then it's minus cos squared theta. Yes. Now that's good news because I feel like I've seen this 1 minus cos squared theta before. I feel like it's like an old friend who's come to visit. Now, what could I rewrite 1 minus cos squared theta as? So I know I've got a sine of theta. I'm busy figuring out what this can be replaced as. Well, exactly, this is going to be this. But, oh my goodness, this is working out so nicely because now this over itself is 1, and 1 does nothing. And so the final answer must be just the sine of theta. So that whole thing over here is equivalent to just the sine of theta. And if we look at what we did, we had to factorize. Then after factorizing, we had to substitute or sub, and then we had to cancel. And that seems to be the 3 steps that we use to get to that. Okay. So now, you guys have handled all these types of questions fine so far, but I want to ask you, if I give you a question like this, how is this one different to what we've been doing so far? What is different about this one compared? If this one says, in fact, I'd love to hear someone's voice or someone to give me some ideas. What's different about this type of question? We are proving or show that, yes. So it doesn't say simplify. It says show that or prove that this is equal to this. Amelia, you know this one exactly. You have to pick a side. There are two sides. There's a left-hand side and there is a right-hand side, and you need to show they're equal. Now, what we normally do is we work with the more difficult side. Which side to you looks the more difficult? Definitely the left-hand side. So we write down what the left-hand side is. And now we are playing back in the world of the questions we were doing earlier. So I look at this and I'm going to try and simplify this. What should I do first? If I want to simplify that left-hand side, think about what identities you've learned about so far. What do you think could be replaced or substituted? What's standing out to you? What's saying, pick me, pick me? It's like jumping. It's like a minion hand that is, yes, okay. It is, where'd my pen go? I feel like it's this sine squared theta plus cos squared theta, which I actually know must be 1. Okay, but here's another problem. My left-hand side, I need to prove that it's the same as this. This has causes in it. This has tans. So clearly, I need to do something to this to change it. What should I change? What could I change to help me here? Change the tan to sine over cos. Yes. And because this is a squared, I need to make this sine squared theta over cos squared theta. Okay, we're getting warmer. We're getting much warmer, but we're not there yet. If we look at where we are going, the promised land is 1 over cos squared theta. We have 1 plus sine squared theta over cos squared theta, but a bigger problem is we have two things separate, whereas where I want to get to is only one thing. How can I put the green thing and somehow connect it to, let's say, does anybody have an idea for how I could replace 1? What could I replace 1? Oh, actually, you know what? I'm going in circles here, aren't I? Okay, but follow me on this. Would you agree with me that, okay, let me be very sneaky. I'm going to teach you this trick. Does everybody give me a thumbs up if you believe that cos squared theta over cos squared theta is 1? So give me a thumbs up if you follow that cos squared theta over cos squared theta is 1. Okay, you follow me on that. Now, the reason I did that was I really wanted to stick these two together. And the good news for me is that because the denominator here is the same as the one here, when you add two fractions and they have the denominator the same, all you do is write down the same denominator. But what is going to be on top now? What is going to be on top now? Well, I think it's just what was here already. But, oh my goodness, now I'm getting excited. Cos squared theta plus sine squared theta. I've seen this before. It's just 1. And you know what? That is exactly what I was looking for. It's the right-hand side. So you know what? I have now proved quite a difficult question. I have proved that the left-hand side that I started with is equal to the right-hand side, which is what I was trying to do in the beginning. Now, this is what we're going to do in the next lesson. We are going to take the skills that we've learned in this lesson, and we are going to apply them to these proving type questions. But we are going to do one more question for tonight where we deal with this idea again. So we are going to do question number 1. In fact, let me actually even leave the other part there so you can see it. We are going to try and do question number 1. So I want you all to try and prove this identity in yellow. And the way you're going to do it is you're going to start with the left-hand side because that's the more difficult. Yes, Stephen, hi, how's it going?
Hi, sir.
How can I help?
So I've been experiencing, I would say I've been having problems in my team closing, like during the lessons and stuff. So that's why
Okay.
I've been going in and out of the classes.
No, I understand. It's the internet is like that. What I would suggest, Stephen, is look, I know there's nothing you can do about it. Just whenever you've missed chunks, make sure you look at the recording before the next lesson. But I understand that's the nature of the internet, so you don't need to worry too much. But now that I have you, Stephen, have you seen these left-hand side, right-hand side questions before? You know, where you have to prove the one side is equal to the other. Just give me a thumbs up if you
Yes, I
have.
have,
Yeah, okay.
I have seen this one.
Starting this question, where would you start? This one in
So I
yellow.
would try to get the same denominator.
Okay. But do you remember the technique where you work with the hardest side? If I said to you that I want to work with the left-hand side first. So on the left-hand side
Yes,
is that. Would you be okay with me pulling the left-hand side out like that?
yes, sir.
Okay, now the goal is to somehow make this left-hand side equal to the right-hand side. If you had a choice, what would you do to try and get that process moving?
I would have tried
What,
simplifying it.
okay. What tool would you use?
Yes, sir.
Yeah.
So I'm not too sure on that one, sir.
Okay. Can you see this tan X over here? If I
Oh,
said to you,
yes, yes,
is
yes,
there
yes, sir.
anything you could replace tan of X with, what comes to mind?
Sin over cause.
Yeah, okay, so what I'm going to do is I'm going to write this as that, and then I'm going to write this as that. Now, we're not home and dry by any means, but are you okay with what I've done so far?
Yes, sir.
Okay. Now I'm going to hand over to your classmates because you've helped us the first part. So I
Yes,
need
sir.
some help. I want to stick together this sine x times sine x over cos x plus cos x over 1. I want to bring them together, but I'm stuck. I need to do something to allow me to stick them together. What should I do? Who can help me out here? I feel like these denominators are making me irritated, and I want someone to show me how I can deal with the problem of different denominators. I am remembering that if I multiply the top and bottom by the same thing, that's good for me. It doesn't change the value of the fraction. Does anybody kind of see the sneaky hint I'm giving you? I was thinking, couldn't you times the top and bottom by the cos of x? Yes. So if you times the top and bottom by the cos of x, you're not changing the fraction. But what is so cool about that is you have sine squared x over cos x to start with. And then what you're going to have is you are going to have cos squared x over cos x. Now, this is good news because I've made it so that the denominators are the same. I times the top and bottom by cos x. And what that forced it to happen is it forced it to have the same denominator. Now, what should I do next? I think that the denominators are the same. That was the whole point. So all I need to know is what is in the box over here. What has to go in the box on the top? I think it would have been sine squared x plus cos squared x. And I know from earlier in the lesson that in fact, that will end up being 1. And that is fantastic news, because if I look at what I was starting with, I wanted to get to 1 over cos x. So I can say the left-hand side is now equal to the right-hand side. Much harder question, but the good news is in the next lesson, we will be dealing with the questions 2, 3, and 4 and other types of trig identity questions. So before we finish tonight, I want you to give me a score out of 10 about how you feel about this topic. 10 would be like perfect understanding. 0 would be none. I know these last 2 are a bit harder, but how are we feeling about, do we feel like we're on the move? Okay, now that's fantastic. All right. Guys, I just want to say well done for coming today. I know that it takes